Welcome to another day on the Journey Shake Chem. Well, tomorrow's a big day. You have an assessment coming up, so we need to review all the materials. So please do the warm-up to the best of your ability, and I'll see you in a moment. In number 1, we are practicing more of the equations. And the first thing I see is that I have an acid anhydride and a base anhydride. I know that an acid anhydride plus a base anhydride will give me a salt. Now, whenever I see an acid anhydride, I have to figure out the charge of the nonmetal of the acid anhydride. Oxygen is -2. There are 3 of them. That gives me a -6. Compounds are 0. And there are 2 nitrogens. And in this case, nitrogen is +3. Now, there are only 2 polyatomic ions with nitrogen in them. And they are nitrate and nitrite. And I know it has to be one of these 2. Because when we add the acid anhydride and the base anhydride, we get a salt. And we have to have a polyatomic ion because there's so many oxygen atoms here. Now, in nitrate, the overall charge of the polyatomic ion is -1. Oxygen is -2. There are 3 of them. That gives me a -6. In this case, nitrogen is +5. That's not the one that I'm looking for. So obviously it is nitrite, but we're still going to go through and solve for this nitrogen. The overall charge of the polyatomic ion is -1. Oxygen is -2. There are 2 of them. That gives me a -4. Therefore, in this case, nitrogen is +3. And that is the one I was looking for. Now, I know that I get a salt. And a salt is a metal with a polyatomic ion. So barium is my metal. And I figured out that my polyatomic ion is nitrite. I still must balance my formulas, and barium has a +2 charge, and nitrite is -1. The common multiple between 2 and 1 is 2, so I must have 2 nitrites. Now, this salt alone does not help me figure out what the resulting solution is. I must add water, just like we did in the lab, and today was the day that you turned that in, and so I know that you're familiar with this. I'll add my water, and I know that they all do the do-si-do. And the inners and the outers will trade places. I know that I'll get an acid plus a base. My base is a metal with a hydroxide. And my acid is my polyatomic ion beginning with hydrogen. Barium hydroxide is a strong base. And nitrous acid is not one of my 7 strong acids. It is a weak acid. When one is strong and the other is weak, I have to figure that the strong one is going to win out. And therefore, this one will be basic. The resulting solution will be basic. Number 2 is another one of these because I think we need to challenge these and try them again. Now, here is a base anhydride and an acid anhydride. Notice that they're not always in the same order, so you need to be able to identify what type of compounds they are. The acid anhydride, I must figure out the oxidation number of the nonmetal. Oxygen is -2. There are 3 of them. That gives me a -6. There are 2 iodines, and in this case, iodine is +3. +3 is a popular number today. Now, I have 4 possible polyatomic ions that I could choose from. It is either periodate, iodate, iodite, or hypoiodite. It must be one of these. I must solve for the oxidation number. The whole polyatomic ion is -1. Oxygen is -2. There are 4 of them. That gives me a -8. In this case, iodine is +7. That's not the one I need. Oxygen is -2 times 3 is -6. This polyatomic ion must have a charge of -1. And therefore, in this case, iodine is +5. That's not the one I want either. I set my polyatomic ion equal to its overall charge of -1. Oxygen is -2. There are 2 of them. That gives me a -4. Iodine in this case is +3, and that's the one I was looking for. Now, since I've come this far, I might as well do the last one. It's good for you to see, and you should be able to do this as well. Oxygen is -2. The whole polyatomic ion has an overall charge of -1. And in this case, iodine is +1. But the iodide is the one that I want. This one here is the one that I want. Now, I'm moving over here, make some room, and I know that a base anhydride plus an acid anhydride is a salt. And my metal for this salt is nickel. Nickel here has a +2 charge because oxygen is -2 and compounds must be 0, so nickel is +2. So nickel must be +2 here. And I determined that my polyatomic ion was iodide. And that is -1. So I must have 2 of them for my compound to be equal to 0. Now, because it's a salt and this is a challenge, I have to add water, as I did in the lab, to determine what my parent acid and my parent base are. I'm going to do the do-si-do. I get nickel 2 hydroxide and iodous acid. And both of these are weak electrolytes. This is a weak base, and this is a weak acid. So when they are both weak or they are both strong, my resulting solution will be neutral. We've had lots of practice with this, and I hope that you're getting better and feeling more comfortable with that. The last one begins in hydrogen, so it's an acid. Lead 2 hydroxide is a base. An acid plus a base will give me a salt plus water. In these, the polyatomic ion will stay together as a unit because they're sharing electrons. So my products are water. I always get water. An acid and a base always give me water. And the salt. And a salt is a metal with my polyatomic ion. And I must get the correct formula. Lead has a +2 charge, and bromate has a -1 charge, so I need 2 bromates to get the compound to 0, and that's critical for me to do. So that was how we do number 1. In number 2, I'm deciding what type of a compound something is and if it is a weak, strong, or non-electrolyte. Now, my first compound begins with hydrogen, so I know it's an acid, and it is one of my 7 strong acids. So it's an acid, and it is a strong electrolyte. Carbon dioxide is an acid anhydride. And acid anhydrides and base anhydrides are non-electrolytes. The only electrolytes that we consider are acids, bases, and salts. So therefore, this is a non-electrolyte. Lithium oxide is also a base anhydride, and therefore it is a non-electrolyte. Now, this compound looks like it's going to be a base, but it's not, because by definition, a base is a metal with hydroxide. And carbon is a non-metal. This is actually ethanol, and it's a molecule. We're just going to call it a molecule, and it is a non-electrolyte. It's important to distinguish my carbon compounds. Iron 2 hydroxide is a base, a metal with hydroxide. It is a weak base and therefore a weak electrolyte. Now, this one we had yesterday, it is hydrogen peroxide, and I put it here because I probably should add it to the penguin sheet and make it accept water and hydrogen peroxide. This is a molecule. It is a non-electrolyte. And we did discuss it a little bit yesterday. Now, hydrogen peroxide, when you put it on your injury, it bubbles. That's the oxygen that's being given off. And it's the oxygen that kills the bacteria. That's the part of it we like. So we get water and oxygen gas that comes off. And it's in a brown bottle because it reacts very easily with the light. So we try to keep it dark so it stays as hydrogen peroxide for longer and not breaking down to form its water and oxygen gas. And that's the answer to number 2. At this point, I would like to do a little review with you. On the penguin sheet, all the information that you need to identify compounds and acids, bases, and salts, and non-electrolytes is all there. But I want to go over it again. Now, the number, the prefix and the suffix depend on the number of oxygen atoms. If I have 4 oxygen atoms, my polyatomic ion is going to be perchlorate, perbromate, periodate. The only difference is which element I'm putting in there. However, if it begins with hydrogen and it's an acid, it must have an acid name. Perchloric, periodic, perbromic. If it has 3 oxygens, then it is the polyatomic ion just ends in ate, bromate, chlorate, iodate. If it's an acid, it's bromic acid, chloric acid, and iodic acid. If it has 2 oxygens, the polyatomic ion is bromite and iodite and chlorite. If it's an acid, it's iodous acid, chlorous acid, and bromous acid. When we have 1 oxygen, it's hypoiodite, hypobromite, and hypochlorite. If it's an acid, it's hypobromous acid, hypoiodous acid, and hypochlorous acid. If there is no oxygen, then our binary compounds come in and it ends in IDE. And the acid name, however, would be hydrochloric, hydrobromic, and hydroiodic. Now, the strong acids, there are 7 strong acids that you can find on the penguin sheet. If it's an acid and it's not one of those 7 acids, then it's a weak acid and a weak electrolyte. The strong bases are group 1A and 2A with hydroxide, except for beryllium. If it's not one of those, it's a weak base and a weak electrolyte. Salts, all salts are strong electrolytes except for the mercury salts. That's the only one you have to remember. If mercury is in there with a nonmetal or mercury is with a polyatomic ion, then it is a weak electrolyte and a weak salt. Those are the 3 major categories of electrolytes. Now, electrolytes are electrolytes because when we put them in water, we saw the light bulb go off and they dissociate into ions. The ions allow the current to flow through. We have to be able to allow those electrons to flow for the current and the electricity to go through. It does not generate electricity. It only completes the circuit. Therefore, we call them electrolytes. And acids, bases, and salts are our electrolytes. That was a little bit of review for you, and I trust that you're going to go over your materials and your warm-ups tonight. The review sheet that you're going to go over today with your facilitator has all the types of questions that you're going to get on the assessment. There are a couple of short answers, and there are 5 equations that you have to do. Each one of the equations is worth 5 points. So that's 25% of your assessment. The rest of it is naming to formulas, formulas to names, identifying weak, strong, and non-electrolytes, and identifying compounds as to if they're an acid, a base, a salt, an acid anhydride, or a base anhydride. Now, I know that you can do it, and I know that you're going to look over your materials tonight so that you can do well tomorrow. And I'll see you tomorrow. Bye.